Welcome back. We're continuing our work in Module 4, Topic 1, Lesson 3, Activity 1. We are breaking this activity up into two sets. It says you have used different sets of numbers, including the set of natural or counting numbers and the set of whole numbers. Identify the numbers from the sort that are in each set. So 4A says natural numbers. Natural numbers, they say, or counting numbers. That's a good way to remember it. Counting numbers, they're the numbers when you were just a little toddler learning how to count, and you would just start with 1, 2, 3. Those are the natural numbers. You were naturally drawn to just those. You were naturally taught just those. So the natural numbers from the set, as I look back at this, those would have included 24, 9. It also would include technically absolute value of -3 because that is essentially 3. Same with absolute value of negative 452 because it is essentially the number 452, and the opposite of -9, which is 9. Whole numbers. Okay, so what's different between counting numbers and whole numbers? Whole numbers are the counting or natural numbers. Plus 0. So it includes 0. So basically, it's going to be the same list from above and 0. Moving on. It says, take note, the 3 periods before and after specific numbers in the set are called an ellipsis, and you use them to represent infinity in a number set. Throughout this topic, you have been learning about the set of integers. The set of integers includes the set of whole numbers with their opposites. You can represent the set of integers as, and then it shows you the set of, so it has the ellipsis here, the dot, 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 -3, -2, -1. Remember, 0 is part of the whole numbers, which is what our definition says. Whole numbers and their opposites, 1, 2, 3, and then the dot, dot, dot. So this means starting at negative infinity all the way to positive infinity, those whole numbers, including zeros. So from the sort, it would be the same as, same as 4B. So that 24, 9, absolute value of -3, absolute value of -452, and so on, the opposite of -9, 0. But then it's also now going to include the negative numbers. So -3, -452 from that set of numbers. Sorry, I just had to peek at my other sheet with the numbers that were in that sort. Okay, it says now that you know about the set of integers, we can now define the set of rational numbers. The set of rational numbers is the set of numbers you can write as a over b, where a and b are integers and b is not 0. So basically, you can write them as a fraction where the denominator is not 0. So let's write that. Write as a fraction, denominator. I use a pencil. I have the word demon, literally, yikes. Denominator. That's better. Is not 0. That was kind of freaky, don't you think? I don't know if you watch this because you'll come in and talk to me about that. Identify the numbers from the sort that you can include in the set of rational numbers. So basically, if you go back to that list, so the rational numbers include everything we've done on this page and fractions. So as we look at that list, let's see where it is. I only see some written as a fraction, but this could be written as a fraction too, right? And so could any of them. 1/2 is a fraction, but so is 2.5%. I could write that as 2.5%. So that's really a fractional value as well. So basically it's going to be all of them. So every number can be in this sort here. They're all considered rational numbers. We're going to pause and move on to activity 2 in a new video.